Morning everybody, this is Stephen Pugh. I want to do another video for you. This is a video that's going to be about, we're going to begin to be talking about routers again. By the way, just to let you know, when I was doing these videos, I was doing them all quite quickly, and so I made a little mistake. So sometimes when you listen to a video, it'll say this is video 16 when actually it may not be actually video number 16. It's just that I got them in the wrong order. The title that's above the video will always be the correct number, so don't worry about if I say something incorrectly when I'm talking. Okay, go by the number that's above the video. So we're going to talk about jigs. Now when we're using a router, there is a thing called a guide bush collar, and this is something that's fitted into the base of a router, and it's been specially designed. Every machine will have one, at least it'll have one when it first comes, and it's a special thing that fits in the bottom, and it can be screwed in with some special little machine screws. They must be kept because they're a very, very special size. And what happens is this puts onto the bottom of the router a collar. A collar is a circular thing that sticks up, like my collar does. What that collar does is it gives a sort of a small internal fence. So the cutter then can stick down below that internal fence, and that means that you can then run that collar around jigs. I mean, a typical example, of course, is a worktop jig, you know, like kitchen worktops. You can put that jig on top of the worktop, and you can use that little collar to run around the jig for you. And this is an exceptionally useful device. It's sort of a little bit like a circular fence that surrounds the cutter. Now this means that you can use all sorts of jigs. You can use it for worktops, you can use it for cutting out hinges, you can use it for cutting out locks if you've got the correct jig, you can use it for cutting dovetails. And this is a particularly useful device. It's one of those things which once you become familiar using it, it will just go on, and you will find lots more uses in time. So that's routers dealt with. Now we need to talk about sanders. Now with sanders, there's different types of sanders. We're going to start talking about the belt sander. A belt sander is a fairly large sander where there's a continuous belt of sandpaper. These continuous belts of sandpaper are made of cloth, so they're very robust indeed, and they come in various paper sizes, so you can have rough to smooth. You can have 60, 80, 100, 120, 180 and 240. Now starting with 60, that's the rough grit, and it goes right the way up to the very fine grit, which is 240. The thing about using a belt sander, it's not designed to rip into timber. It's designed to float over the top of timber. So what we do when we're operating it, we don't press down, we hold it and allow it to glide. Allow it to glide as if it's a sort of let it glide as if it's a sort of a hovercraft floating on water. We just let it glide over the timber. We don't let it go across the grain, generally speaking. We try to keep it going up and down the grain. And now these very coarse papers, they can remove quite a lot of stock, remove quite a lot of timber. So we try to avoid doing that too much. To remove a belt is very simple. If you tip the machine on its side, you'll find that there's a long lever. When you pull that long lever, it causes one of the wheels, the one at the front, to just come back a bit. And when that one comes back, the belt then becomes loose, and you can just slide it out, and you can slide a new one back in. Now you need to be very careful when you're putting the belts back in, that you put them in the right way round. If you look at the belt on the inside, there will be an arrow a large arrow, and that's telling you the direction that the blade will, that the belt will go when it's in the machine. So you need to make sure it's the right way around when you're putting it in. Then you slide it into place and you put the lever down again. Now, before you actually operate the machine fully, you need to turn the machine upside down so the belt is facing upwards, and just gently squeeze the trigger and allow the machine to just turn a little bit. And what you'll discover is sometimes the belt will turn a little bit to the left or a little bit to the right. It's very important that you don't let it go off the wheel, and it's very important you don't let the belt bury itself into the side of the machine either. So at the front, on the front wheel, there's a little wheel that you turn, and when you turn that, it enables the belt to be tracked. As you turn it on, you can see that when you turn the knob, the belt will move from right to left, and then what you do is you adjust it so that the belt is running in the center. So beautiful little tool. You can get big ones and little ones. The big ones are really great for doing overall sanding, and the little ones are really great too. Sometimes there's some small machines and they're really good. Now let's talk about the Orbital Sander. Now the Orbital Sander is a different type of sander altogether. It has papers which are attached each end. So again, you can use the different types and different grades of paper, but you attach it onto the two ends of a pad. And then when you turn the machine on, inside the machine there's a small spindle that has a weight attached to it on only the one side. So when it's turned on, that weight spins eccentrically, and so it causes the machine to vibrate. If you turn it over and put a little pencil mark on the paper when it's stationary and then turn it on, you will see a little circle. That little thing will travel in a circle, and that's the thing about an orbital sander. It actually vibrates, and it actually does this sort of action. It actually just scrubs very, very, very lightly. So these machines are really very cleverly designed, and they're all pretty well designed now, whereby they suck the air away from the timber and put it into a bag. That's a classic thing now. Another type of sander is called, let me just think what the official name is. It's a, I don't see the word in front of me. So this is another type of, I think it's called a random orbital. So what this is doing is the paper is still moving in this little circle, but the machine is also traveling in a large circle as well. So what that does, that makes that little circle be quite random. Its circle still is working, but it's actually going around as well. So that means that it has much more ability to sand, because the actual sandpaper is moving much more. Of course, there's little palm sanders. These are little tiny ones that you hold in your hand, and they're also superb as well. So the different types of sanding machines all have slightly different operations. They're all good for certain things and not so good for other things. Just to let you know, most power tools nowadays come in specially dedicated boxes. In fact, some manufacturers will make them into boxes that are all stackable. They're all identical box, top and bottom, but they may be a different depth. And so that means, of course, that they're very, very easy to stack and very easy to keep tidy, either in the workshop or in your van. Now we're going to turn to the subject of fixed machines. The big circular saw is what we're going to be thinking about first. And now this big circular saw, it's very important that you familiarize yourself with all the main parts of the circular saw. So you've got, for example, a groove in the bed of the saw for a fence. You've got the riving knife. You've got the top guard or the crown guard. They're two different things, but they're doing a very similar thing. You've got top extraction sometimes on the top guard or on the crown guard. You've got the saw fence. You've got a cross-cut fence. So these are two different types of fences. You just need to learn what these are all about. You've obviously got at the front of the machine a stop and start button, and you've got a rise and fall wheel. So as you turn the wheel, so the blade goes up or goes down. There'll also be another wheel which causes the blade to cant over to the right or the left, whichever way you want it to be. Some machines don't have that feature, but nearly all of them will. There will be an extraction pipe at the side which takes out the sawdust that's collecting in the bottom of the machine. It's very important that that machine is not allowed to eventually clog up. They do actually fill up if you're not careful, but the extraction pipe will remove most of that most of the time. There's an isolation switch. Now, the isolation switch is very important because apart from the on and off button, the isolation switch isolates the machine completely from the electricity. So when you're doing any adjustment, you need to be very careful that the machine is completely isolated. You know, many people are very good at doing their work, and then when it comes to making an adjustment, they make an adjustment, and at that moment they have an accident because the machine may still be running, or the machine might accidentally turn on. There's also a place for the guards. There's also a screen guard, so that the belts and the pulleys that are inside the machine are not able to be touched when they're in motion. There's also an extension table, generally on the side or on the back. Now, the extension table is very important because it is a legal requirement that a machine should have an extension table at the back so that timber can be pulled off, and there's a regulation size. There's a little bit of debate about what that size is. If you look in some books, you'll see that that they state it in different ways, but the main thing is that from the back of the cutting circle, as it touches or comes out of the bench, to the back of the extension table should be 1200 millimeters. But what that means is it's 4 foot. What that means is that the person that's helping you to pull timber off the back is unable to reach that far and hurt himself by touching the blades, touching the saw blade. So before you use a machine like this, it's very important that you check various things. You need to just check that there's nothing missing on the machine. Nobody's taken any guards off. Nobody's taken any fences off. These are just obvious things. Also need to check the wiring, making sure that everything is operating properly. Everything appears to be correct. And what I would normally do is just press the green button and just make sure that it's going to work correctly, and then I'll just turn it back off again. That's just a quick check to make sure the blade is working correctly. When you do turn that on and off, you don't want to be in line with the blade. If anything is stuck in there and it comes flying out, you don't want to be in line with the blade. You don't mind if it passes you, but you don't want it to hit you. Lastly, any faulty switches on a machine, the machine needs to immediately be condemned in use, and it needs to have a sign put on it saying out of use. An electrician needs to be called to check everything. If the blades are dangerously blunt, if they've got lots of teeth missing, okay, if you've got one teeth missing, it's bad. If it's got 2 or 3 missing, then it's exceptionally bad. So you just need to check the, and also with the machine all turned off, you just take a stick and just poke the blade and just see whether it's running freely. These are all checks. You probably could think of some more. I mean, for example, you might want to just make sure that the debris that might have been used on the previous cutting operation is not still on the table surface or on the floor around it. You know, this is a very common habit of people just leaving a machine in a dirty state, leaving it with debris around, and so that all needs to be cleaned off. Now, if the machine has a top guard that is attached to the riving knife, then generally speaking, what we do is we lower the whole assembly so that the top guard then is only about 12 millimeters away from the surface of the timber that's being cut. Okay, it's about 12 millimeters. You wouldn't want to lower it to the point where it's actually just about poking through the timber. And the reason for that is because if in the operation the timber just slightly moves up or down a bit, then the saw will fail to cut it. And if it fails to cut it, there is a tendency for the saw eventually to just grab hold of the timber and throw it. If the top guard is, if the machine doesn't have a top guard and has what's called a crown guard, then the machine must be used with the saw in its maximum height. Now the reason for this is because not only do the teeth cut the timber, but they also have a tendency of giving it some downward pressure. If the saw's at the top, it means the teeth that come into contact with the work are going to be cutting downwards. You wouldn't normally want the teeth to be cutting forwards. You want them to be cutting downwards, and that means the blade needs to be at its full height. Now the saw blade parts, the actual saw itself, we talked on a previous video how that the teeth can have a positive hook, they can have a forward action like that, so from the point of the tip to the middle of the blade is actually it's actually pointing forward beyond that. There's also a negative hook. Now a negative hook is where the tooth is facing backwards when you take a line to the middle of the blade. Yeah, just different operations need a slightly different tooth shape. It's good to familiarize yourself with some of the features of the names of parts of the saw. I mean, there is a thing called the gullet. This is the large circle in front of a tooth. Those gullets are very important and they need to be kept clean because it's the gullet that has another important effect. As the as the machine is spinning, as the saw is spinning, that gullet creates an air pocket which enables the sawdust to have somewhere to escape to. So it's very important that those gullets are kept clear. And then of course we have the tip of the teeth, we have the heel of the teeth, which is the back end, the other end from the sharpie end. We have the back, we have the top, we have the point, we have the face. All these are words. These are just words to describe the different parts of a tooth on a saw blade. There is a word called kickback, which is a very familiar word. Kickback is when something goes wrong and the saw grabs hold of the wood and kicks it, throws it back to you. Sometimes these kickbacks are just a little bit of a shudder, but sometimes they can be serious and the teeth can actually throw the wood. So this means that when you're working on a saw, you never stand in front of the blade. You always stand to the right hand side and the timber's passed across your body. If ever there's a kickback, the timber will go flying past you and will never come flying towards you. Now there is a thing called the riving knife. This is a piece of steel, a little bit like a knife, that sits behind the saw, and it's a common practice for some people to take the riving knife off. That of course is illegal. It's a legal requirement that you must have a riving knife on a saw at all times. And the riving knife must be close to the blade. It must be to within 12 millimeters. Some people talk about 10 millimeters and 8 millimeters, but the 1974 regulations state that there must be a gap not exceeding 12 millimeters. Now that gap is not, some people bring the riving knife either too far away from the cutting circle or too close to the cutting circle. Both of them are incorrect. I talked a moment ago about the gullet having a little pocket of air to throw away the debris. Well, if the riving knife is very close indeed, then it interferes with the air that's actually throwing away debris. The riving knife itself is a tiny bit bigger than the overall curve of the saw. So the curve of the saw is where the two teeth cross over, and it's the overall gap that cuts on timber. The riving knife is designed to keep them apart after it's passed through the saw. Some timber has a tendency to close up, you see, so the riving knife keeps them apart. So that's very important. And of course there's regulations about the minimum height that the riving knife should be above the table, which is 225, and the maximum height that the riving knife can be below the overall cutting circle. It must only be 25 millimeters maximum. So, having said all those regulations and those details, what about its use? Well, the using a circular saw is one of those things that you need to just be experienced at doing. You can only really learn how to use it by actually doing it, and we can't demonstrate it when we're actually doing a video like this. But there we are. It's one of those things to learn to do. We could talk about how the blade is removed from the machine, but that's something more experienced than talked about, and everybody that is in the wood occupations courses will need to be able to learn how to do that. It's very important when you put in the riving knife, for example, that you have the correct washers in the right place. We don't want the riving knife to be offset to the right or to the left. It's got to be in the center of the saw blade, and all these things are much easier to be explained when you are doing it yourself and doing it again and again. Okay, I think that's pretty well it. Oh yes, one thing, on all circular saw machines there will be a notice. It's a legal requirement that there should be a notice. It'll be a notice telling you what is the minimum and maximum diameter of blade that this machine is allowed to have. That's very, very important. If you change the diameter of a blade, it changes the speed of the saw at its circumference. And there also needs to be two other things. There needs to be a notice on the wall next to the machine stating who are the people that are fully qualified and competent in being able to use that machine. We get people wandering into the workshop, turning the machine on and making a cut. Well, you know, this needs to stop. Only the people that are officially competent and the people that are officially qualified should operate a machine, and it is a legal requirement to have a notice on the wall stating who are the people that are qualified to use the machines. And one other thing, you know, there's so many things that come to mind when we talk about these things. It's very important, okay, that the lighting that is above a machine should not be of the old-fashioned strip lighting. Now, I don't know whether you know about these old-fashioned strip lighting. They have a tendency that there is a flash of light that goes from one end to another, which is very fast, and most of the time we don't even see it with our eyes. But we all know what it's like when that flashing effect slows down, and as the tube gets older and older and older, so it slows down more and more and more, till in the end your eye, when you look away, can nearly catch the flickering. Now that flickering is a stroboscopic effect, and when the flickering slows down to the point in which it syncs with the blade, it has the effect of showing that the blade is either stationary or traveling backwards, okay, because it's flashing a light at it, and it has the effect of making that machine look as if it's stationary and the blade look as if it's stationary. That, of course, is exceedingly dangerous. You can look at a machine, you've got earmuffs on, you can't hear quite the same, you've got goggles on, you can't quite see the same, and you look at the machine and the blade is either stationary or it's actually moving slightly backwards. That's the stroboscopic effect, and that means that the lighting that's on the machine is very dangerous indeed. Well, there's an awful lot of things for you to think about. You've got the 12 questions at the bottom under the description. So we look forward to catching up with you on the next video. Have a nice day. Bye for now.